I guess first of all, thanks to Lipscomb University for hosting this, and obviously thanks to everybody associated with BSides, all you guys for devoting time, and Adrian as well, obviously for going everywhere and recording all these things and giving up all his gear to make all this happen. To where when I can think of even several years ago when the only things that I would go to, I was fairly new into the this field, and so I would always see Adrian's recordings, and if not for Adrian, I can't think of a lot of other people who would go around recording all these. But so today, we're going to talk about flow data. It's kind of the best thing to really wake you up in the morning. So I'd say it's probably better than all this coffee you're drinking, because you're going to get really excited about it. There's nothing more exciting than looking at line-based text data. So I'm also going to kind of give you an introduction to Flowplotter and Flowbat. And Silk is a NetFlow solution I'll talk about in a minute, that if you don't know what those are, then Flowplotter and Flowbat won't make sense right now, but they will in a second. So I guess first of all, who here is in charge or associates themselves with either a NetOps group or a SecOps group that does defense? So I guess quite a bit. Who here uses a flow solution at all, within your group? Okay, so very few. This will be very helpful. So at the end of this talk, essentially, there's going to be no reason not to deploy something unless you have a 100 gigabit network, apparently. So, but even then, maybe if you have ridiculous amounts of money. So my name is Jason Smith. I am a Kentuckian. It took me, should have taken an hour to get down here, but it took me an hour and a half due to construction on I-65. But I'm also a big car fan. Love rural areas, love taking junk, throwing it together, making death traps out of it, sitting in it, and driving it. And I also like Raspberry Pi. So like what you see here is a dune buggy that a buddy and I built several years ago that recently, it's now a war driving dune buggy. Does all kinds of fun things that probably you shouldn't do outside of war driving as well, but it's pretty fun, little thing to do up there. A lot of space to do it. I worked for state and federal agencies. Worked with the DoD for a while. Moved all around the U.S. for that. Moved up to Frankfurt to work with the state of Kentucky to help out with all of their defenses. And now I'm with hired on to Mandiant, and now they're obviously FireEye. So, I guess before I start, the shameless plug for Applied Network Security Monitoring, Chris Sanders and I, we wrote this with the hopes of getting, kind of every defensive group into, a very good posture to do their job as well as they can. Even if they're doing it great already, it's also a great reference. So it'll tell you, how to set up, flow solutions. It'll tell you all kinds of stuff. And even since we released this, the stuff I'm going to talk to you today is more of, here's how to get it set up in like 15 minutes instead of, taking forever to set up, all these, VMs to test it and then to, build these flow solutions and then get a front end and all these other things. This, what I'll talk to you today really takes this, to another level. It's worth noting that 100% of our author proceeds go to charities, things like Hackers for Charity, the Rural Technology Fund, and more charities as well. So the big agenda today is really what is flow data. For anyone who isn't using it or who might think of they want to use it, and also what can you actually do with it? How can you do it? It's obviously very useful for security monitoring. It's very useful for incident response. But one thing I do find in certain situations is that even network operations groups, you would think they would all have some sort of flow solution set up, but it's not very realistic. You have a lot of older environments that have older routing equipment that doesn't even support it. Also, it's we go back to like sample data that when you have security ops messing with NetOps, it's like, oh, we can give you flow data all day long, but it's all sample data. There's not a lot of it, and in some cases that's all you can deal with, and that's fine. But I'm going to talk about ways that if you already have, say, port mirrors set up and, certain locations that, why not go ahead and collect at those locations so that everything that's in your alert data matches up with what's in your NetFlow data. So, the big challenges that we have in NSM they're not really a matter of not having the abilities to do things, but usually it's not having the resources to do things. So take PCAP, for instance. It's very easy to collect. There's a ton of tools. There's NetSifNG and Daemon Logger and DumpCap. And there's a lot of different PCAP tools that you can use to collect data. There's a lot of different tools you can use for detection of bad guys through PCAP data. However, a lot of that is a matter of churning through everything, not really the individual hunting through data. So you have things like, obviously, Surcot and Snort. They can parse through PCAP. They can parse through, full packet captures. Bro does a pretty good job of taking it, in a kind of a different step, a different road that does, some behavioral stuff if you have the skills to operate Bro efficiently. And there are a lot of different tools that can take PCAP and, parse it down into, strip the header data out of it, do a lot of different things. But, in the end, it's taking PCAP and saying, well, what are the bad things about it? And, how can I get around those? Despite, it giving us, everything we need, except the why, obviously. It's a matter of, it still has a lot of pros and cons. And, for instance, the biggest one that, everyone runs into is that, I can, store a lot of PCAP. I store, a week of PCAP on my enterprise. And it's like, well, the bad guy has been in here for 200 days. So your week of PCAP really doesn't do much to detect the bad guy that's been in here for 200 days and to go back and answer the hard questions on, how did they get in, who did they talk to, where did they pivot from, a lot of different things like that. That lends us to, hunting. We talk about the detection aspect, of using PCAP to do these things. You can't really dig into a huge thing of PCAP without taking, your entire group and, a ton of time. By the time you get done looking through, your week's worth of PCAP, it might be a week and a day. So even your first PCAPs are gone. And then also from an analysis point of view, if you have an alert, it's not a good starting point to go from, alert that shows up in Snorby or, whatever your front end is to jumping straight into your PCAP. I mean, there are solutions, specifically in Snorby. If you have Security Onion set up, for instance, it'll jump straight from, an event to a PCAP, and then you dig down through that PCAP and you find what you need. You do a lot of stuff. Well, already you've wasted a ton of time where you could have pivoted from a intermediate data source straight to that PCAP and where you want to be. So, again, if you're not used to flow data or not aware of what flow data is, that PCAP is kind of everything, and it's great. It's, it's the end all of everything. But, it's like having the full recording of a phone call or a week of phone calls or a week of, 100,000 phone calls. Versus having call logs, which might have your starting times, when those calls, happened, who they happened with, how long were they, just line-based records, for everything that's kind of happened over the course of, X amount of time. So in other words, it's, kind of mountain and molehill. Whereas you can store PCAP, for minutes, hours, days, maybe weeks, you can't really keep that for extended amounts of time. With flow data, there are many enterprises that store it for, months or years, and I've worked in places that store it indefinitely. They have, the sole idea that we want to store all this PCAP, and once we run out of storage, we want this to be modular, that we can add on more storage and keep storing, NetFlow. We can keep storing NetFlow data indefinitely, never stop. They want to be able to go back to any time in the past, that's relevant. Obviously based on, a lot of compliance standards. But, again, I worked for, several DoD organizations, and each one stored NetFlow indefinitely. To give a good idea of how big, this mountain is and how big this molehill is, it's actually going to be a pretty big molehill here. But PCAP, if you were to take the same PCAP and run it through some sort of flow solution, on average, the net flow that comes out of that will be around 0.01 to 0.02% of the size of that full packet capture. So take that and combine that with your storage needs for PCAP. Well, the storage needs you have for NetFlow are 0.01 to 0.02% of that. I mean, it's very, very small by comparison. And so again, if you're already storing full packet capture, there's no reason to go ahead and have a little bit more storage for as much NetFlow as you possibly want. So to really get into what is flow data, it's called session data and flow data, and most people, including me, I've probably already said NetFlow a few times in this talk. But NetFlow is actually a proprietary name from Cisco. It's what they own the name. It's a summary of network communications, not so much every packet. A lot of people are like, oh, we want to log the packets that come across everything. We want to have them line-based, and that's good. Well, that's not really what flow data is. It's a summary of the communications, which may yield results of how many packets are in communication, but every single packet, you're not going to get a lot of detail out of it anyways. What you see here is, it appears, obviously, to be some DNS traffic. Without going into it, obviously, it's unknown, but it's 8.8.8.53 inch UDP. But this is the general idea of what a flow record looks like. It's based on a 5-tuple, which is a source IP, dest IP, source port, dest port, and a protocol. You also obviously have like a time that it's associated with, and then other solutions will tag on durations and all kinds of different things. The very basic NetFlow version 5 is limited to 20 some odd fields that are actually available. But a lot of solutions now, especially if you're capturing things from a software, capturing NetFlow from a software point of view, you'll have using IPFix or NetFlow version 9, which have a ton of fields. Not all of them are used, but there are a ton available. In fact, a lot of commercial solutions that aren't free, they will use those extended fields to kind of gather other information to give context to flows. Flow data, whereas PCAP gave us the who, what, when, and where, we still get most of that, but we don't really get the what here. However, obviously given the trade-off, the speed that you get from flow data versus PCAP and actually pivoting into data, it's definitely worth it. Basically, it's you can think of it as an aggregated record of all your packets, and again, not a communication record of every packet. Here's a nasty example of what flow data looks like. It's a bunch of records similar to what we had a while ago. It's protocol 17, so it's a bunch of UDP, destination port 5030 traffic, to be assumed to be some DNS traffic. So flow records themselves, you can create flows from PCAPs directly. So like if you have a large PCAP repository, let's say you have a lot of malware or something like that, and there are a lot of traffic captures from those, you can churn those through several flow solutions, but most commonly it's basically off the network directly. So you'll have a software solution or something like that pointed directly at an interface, and it's going to draw all that in. It's basically, think of it as kind of like a factory as far as how these flows come in. They're all based on these 5-tuple records that if a different 5-tuple record comes in, this factory worker says, I'm going to take this flow solution that we have, it's right here, it's building up more data. Well, I have another one, it's coming in here, it's a little bit different, either source port, dest port, the source IP, dest IP, or protocol is different, so I'm going to stick it here. Now, while they're both just standing here kind of stagnant, there are some termination conditions that need to be met, and those are, they're basically 3 big solutions, or 3 big timeouts. There's a natural timeout, which is kind of a more logical timeout, where if the protocol is kind of a stateful protocol, or it has some graceful way of tearing down, that let's say YAF, for instance, YAF is a flow meter. If YAF can see this protocol and say, I understand the protocol, I understand what it means when it tries to shut down, then it will go ahead and end that timeout if there's a shutdown. There's also the idle timeout, which means that if, again, this guy has been sitting here stagnant for 29 seconds, at the 30th second, it's going to go ahead and push it forward and store it back, and that's now a queryable flow record. Whereas this guy right here, it's still getting a lot of communications. Let's say it gets communications for 30 minutes straight. Well, suddenly your flow meter's like, well, I'm kind of done with this. I have this configurable active timeout that says after 30 minutes of continuous, a 5-tuple, coming along, I'm done with it. I'm going to go ahead and push it forward. And if another packet comes along, at 30 minutes and 1 second, I'm going to start another one. And it's going to be the same as this previous one as far as the details, but you're going to have a different starting time. And then when it ends up, it might have a different duration. So collection with flow data. So I'm going to kind of ask again, if you don't care, a total, how many people have a flow solution right now? I mean, there's 40 seats in here. And so we have, about 4 or 5 people, 6 people, that have flow solutions set up. Just out of curiosity, if you don't mind saying what you're using, who here is using Silk? Who here is using Argus? That's interesting. So, what are you using? Just if anyone wants to yell it out. Okay. Say again? Okay. Okay. So, and I'll get back to a couple other solutions as well that are completely free, easy to set up. Well, now they're easy to set up. And talk about, kind of what is deployed that's also very easy for people to use. I bet you've all used Argus, or at least most of you in the defensive field have used Argus at some point or other if you've used Security Onion. May have not known it was on there, but it is on there, and it's already set up. Once you deploy it, it's there. But anyways, generation of flow data, again, you can send it from some routers. I'm not going to say all routers. You can't go to your NetOps guys and say, oh, you get these 20-year-old networking devices that were used for whatever. I need you to send me some NetFlow version 9. And they're like, I don't know really what that is because I've been here at the same time they have been, and I haven't really moved at all, and so I don't know what you're talking about. I can't send you that. They don't have the capability of doing that. But a lot of routers can. What you're going to find a lot of times is that it's going to be sample data. Great if you have astronomical amount of data, but not great when you actually want to look at it and find bad guys. That's the big problem with it, is that sample data is just a sampling of the full amount of net flow that you should be receiving. So unsampled data is really what you want to go for as much as you can, and you want to push your resources such that you can do this, just because without it, you're going to see an event and you say, oh, well, I'll look at net flow first. That's what Jason said to do. We can pivot from it. Well, you can't pivot from it if you only have 1% of what you have. Another way to generate it, and the way I usually try to push people into, is that if you already have some sort of port mirror or taps or whatever that you're getting, a full flow of data, you might as well go ahead and set up a software solution on that tap and go ahead and use like fprobe or YAF. I usually recommend YAF just because it's IPFix data, and YAF is unbelievably good as far as how much data you can send it. Talking to the CERT guys that developed it, they will tell you that they can push it to do. I'm not going to put words in their mouth and say unlimited, but they've talked about 40 gigabit networks. It'll easily do, and the largest networks in the world, they deploy it, because it'll handle it. There are a number of other solutions as people have mentioned, but these are free ways of generating the data as far as YAF and fprobe. There are multiple types of flow data itself. I talked about NetFlow. It's Cisco's proprietary thing, but there's SFlow, there's JFlow, NetStream, CFlowD, RFlow, AppFlow, all kinds of flows. Again, I want to talk more actually about IPFix, which can be kind of translated to version 9. Most things that will accept IPFix will also accept NetFlow version 9. So actually collecting it, what are you using? Say you're sending data, you've set up YAF and you're sending data to something. Well, what is actually collecting this data? Well, you can use Argus. Again, Argus is set up in Security Onion already. Argus is pretty cool. It's been around since NetFlow has been around, basically. Carter Bullard, he goes to a lot of the these NetFlow conferences. There's like FlowCon. He gave an awesome talk about kind of the history of flow data, history of actually doing some collection and monitoring. Going back to like the Morris worm and actually looking at the Morris worm and saying, well, how can we actually track this and what can we do? Well, how about this flow thing? We're going to set up NetFlow, and next thing you know, they start making Argus. Very reliable, very fast, has its own built-in collection tool as well on top of its analysis tools. The only problem with it is it's not incredibly well supported. Documentation is lacking in places. Literally, you go there and you get 404, something like that. And I mentioned that because by comparison, I'll talk about Silk in a minute, it really changed that around. A lot of people use NFDump, but it's not really set up in a lot of huge environments. Not that I've ran across, at least. It's pretty easy to set up, though, and pretty easy to use. It also has NFSyn, which is a good way of visualizing data that previous to tools like FlowPlotter, which I'll discuss in a minute, it's not really easily done in these other tools. Silk, which is going to be the bulk of what I talk about today, it's, obviously I'm biased towards Silk because I've used Silk more than Argus. I've used Silk more than NFDump. That's my flow tool of choice. It has a lot of different analysis tools involved, and I'll talk about those in a minute. But traditionally, it's had a more involved setup. Basically, there's infinite ways of deploying this thing. It's deployed across, very large enterprises. The government helped fund it, so naturally, there are members of the government that use it. But it can handle things with no problems. It's set up for kind of like super corporations that have corporations under corporations, and you can deploy it across the whole thing. And one single security operations group can look at this and say, oh, well, here's these sensors. Here's a description of all these things. It's no problem. The biggest benefit of Silk, and I say this both for people that are already mature in the use of NetFlow data, flow data, session data, people that are already matured in that, but also for new people, because it has by far the best documentation of any other flow tool I've ever seen. There's analysis, or analyst handbooks, the documentation for the tools themselves. If you get curious, oh, what is this option? What does it actually mean? You'll find it within seconds. It's very easy to use. Carnegie Mellon should really get props, right now, just because, 2 of the 3 here were developed by Carnegie Mellon, at least funded, and, a lot of research went into it from Carnegie Mellon, Argus and Silk both. Even up until, I think, 2006, Argus or Silk supported an Argus output as well, so you could kind of use the 2 of those if you're like transitioning from one to the other. But since then, I think they've stopped support of Argus's format. But again, Carnegie Mellon, the Network Situational Awareness Group, they push these kind of things. They don't really have probably the ability to really evangelize on it as much as I like to. But hopefully I'm doing them justice by pushing these things forward like this. A word of Silk, if you talk to some of the guys at Carnegie Mellon, it'll handle, as many as 12 billion flows, per day pretty easily. And they have guys, all the time talk to them. So, it's no problem, but can we push it up to, X amount? And, I've never talked to those guys and they ever given me any sort of negative attitude of, well, we reached this stopping point where we can't move forward with it because it can't handle it. They really work forward to really push it to the envelope. So Silk is the system for internet level knowledge. It's going to be what I talk about, the most today. Again, it's Network Situational Awareness Group up at CERT. It has 2 things. It's packing suite and an analysis suite. Packing suite is basically when you send it something from YAF or from your routers or from whatever flow meter you have, the packing suite, RW Flowpack in this case I'm going to talk about, will collect that and say, oh, I want to store this in a certain location, these different folders. The folders being types that are defined by configuration. So if it's in web or if it's if it's internal to internal, they'll have different folders that are referred to as types. Within those, they're time based. The analysis suite allows you to basically do anything that you can think of, outside of just the command line, doing additional modifying. But you can filter and display and count everything and bin everything and do all kinds of stuff. But again, right now it's just a text-based tool. They have iSilk, which is something you can install that's a GUI, but it basically just slightly expands on this. Again, the documentation. If you want to know more about Silk and really how to use it, there it is. Basic Silk collection architecture is you would have a Silk server, RW Flowpack, that probably has the analysis suite on it as well, so that you can go there and do debugging or whatever. You may also give the analyst access directly to that server, so that when it is collecting data with RW Flowpack, it'll store it away, and an analyst can go there and say, "Oh, what do I want? I'll set up a filter and do whatever." And above you see, Senior F-probe should be sensor, an F-probe sensor, router, YAF pointing to it, and then those are all sensors that it has defined that it's waiting for, and it'll sort those by sensor. What you basically need, and what I just discussed, is the general idea is you need some sort of flow source, be it a hardware, software flow source. I'll talk about YAF some more. You also need a Silk server that's going to collect the stuff. And a lot of times, especially if you're at my house, it's the Silk server is also the analysis station, which has the analysis suite on it. If you're in some sort of enterprise, you may have analyst workstations. that query it directly, or you may mirror that Silk data to the analyst workstation depending on how much you have. Again, mirroring that is obviously, you're pushing all that data to however many analysts need it, so that may not be always be feasible. The Silk analysis suite, I'm going to talk about RW filter probably the most because it actually filters through the bulk of the data. So when you say, what data do I want? RW filter is how it goes and gets it and says, oh, well, this is only the data that you requested, or the data you requested not be here. RW cut converts what it gives you into a human readable format. Silk uses all these binary formats just because that's the quickest way to do these things. A lot of people use tools like Splunk for their flow data, but the problem with Splunk is you get say flat files that have non-binary data that aren't really ideal for just for just flow parsing. Instead, they're a big massive data tool that are great for everything. I mean, don't get me wrong, I love Splunk, but they're not always ideal.
I was at a university last. The way we did it is our Splunk license didn't have enough capacity for obviously a large university to handle the flow. So what we did is we just had a cron job that ran across our flow.
Right.
Like I'm going to say about every 15 minutes or so. And it would just convert the flow data to nothing but unique IPs, either source or destination, so it was just a straight line column. And that way, the folks didn't really know the NetFlow stuff could still just drop an IP in Splunk.
See if it's happened, basically.
See the timeline and go, oh, it happened in that bucket of time, and then they could just go do the print.
Okay, yeah.
It was sort of a four-man blue filter.
Right. Yeah, so I guess, one of the big benefits of possibly having it in a binary format is also, though, the search speed of getting the full NetFlow. And I'll show you some, how fast this actually occurs. I mean, I go across, it was 7 million records in, about 3 minutes, and that was on a 512 megabyte VM. 3 seconds on a 512 megabyte VM. And it's really, really fast. It's ridiculous. But RW cut will convert that into a binary format, which you don't want to have all the time. You want to get your filter just right, and then convert to whatever you need. RW stats does stats. RW count will summarize all that traffic into a bunch of bins and let you do some other things to that. So Silk analysis, here's a good example of what your raw output would look like if you just specified, I want to read this, all my data in a human readable form. What you see here is, I've said I want all of those folders that RW Flowpack put everything into, and I want to specify a partitioning filter that says every protocol. And so you're essentially getting every bit of your data, for the given day. If you don't specify a day with Silk, you get the given day that you're on. RW cut then just converts it into a readable format that is kind of ugly and everywhere when you don't cut it down a little bit. So this is another example of kind of the same thing, but we've added in new input filters. We've added in new partitioning filters, and we've kept the output filter. RW cut also has the fields cut down to basically just the 5-tuple. So here you see, dash type equals all, dash start date, dash end date. That's 3 different input options. You only need 1 to get it to work, but that specifies it down to about a week. Then we have 2 different partitioning options where we're looking at only Chinese traffic if it occurred as source IP or dest IP, and a port of 41.142. And then we're passing it to standard out, which then RW cut takes it and prints it like you see here. Here is an example of RW stats. It's doing some stats on a top 10 amount of bytes transferred by protocol. So this obviously only lists just a few, and that's because in the sample data, I said I want a top 10, and that says, well, there's only 7 protocols for this amount of time, so I'm going to give you 7 protocols. Again, this is listed by bytes. You can separate it out and have it listed by records, or you can separate it out by packets, and you can also do like distinct values. So I want to know how many distinct IP addresses were seen by each protocol or anything like that. Here is another stats example. Here we're just showing kind of the top 10 SIP-DIP pairs, and so it's saying look at every SIP-DIP combination, and I want to sort this, and you just read kind of left to right. I want to sort by top and then count 10 for SIP-DIP pairs, and I want to sort it by bytes. And so by bytes, these SIP-DIP pairs had the most, throughput across this network. Here's another example of RDB stats. Hammering on it because RDB stats is awesome. It's top 10 outbound destination country codes by the total amount of records that occurred. Records is kind of a hard thing to really think about because it's not in context of anything else. It's what your flow meter, chose to do. It's, based on, some configurations on timeouts. But we've done the top 10 and sorted those by the destination country codes. So a real-world example, obviously this is not a guaranteed thing, but, if you said, oh, well, I want to look for zero axis. I know zero axis uses the following ports. I want to look at data that's going to these destination ports, and I want to sort it by the top source IPs by distinct destination country codes where a source IP has talked to at least 3 or more destination country codes. Sounds like a lot to think about, and it kind of is a lot to think about. But in the end, it's a pretty simple thing. Like when you take into context what zero access is, it's going to have a lot of communication. You usually see it talking out to everybody, all kinds of different country codes. And this is just an easy catch for any sort of local IPs that might have zero access. Another real-world example, this actually leverages a plugin that comes by default with Silk. It's taking a thing called app labeling. So YAF is looking at things, and it labels things based on, this looks like SSH, or this looks like, some sort of, FTP data or something like that. And it's taking this plugin and saying, well, the ports don't really match up. If the port doesn't match up with how the data actually looks, then I'm going to say, let's go ahead and throw those in here. So we use -- plugin equals app mismatch. Also looking for any source ports that are 1024 and above, trying to get things that look like real communications. And then we're doing a stat for the where the application and desk ports, we're going to list those out, the top 100, which we only had a few in this case that weren't matching up. And so what you have here is you have the application that YAF saw. It said, oh, well, this looks like HTTP data, but then it's like, well, no, I think it's actually Telnet data. And then you have some other things that show up there that it didn't actually see as being legitimate, and that there were like 23 distinct counts, 23 different applications that weren't actually on port 80 that were kind of mixed up. So you might have any amount of different ports being used. So like, for instance, YAF isn't always perfect in its app labeling. It might say, oh, 8081, that shouldn't be HTTP data, when you're like, well, actually, I've kind of just said that's going to be that, and it's running HTTP data, so never mind that. But you could put in additional filters to say, don't look at those things. It's a good way to collect intelligence data, and I'm going to kind of go through an automated way here in just a minute, on how we actually do this. When I say collecting intelligence data, I mean we're looking kind of at friends and family, not only just, bad guys, but we also want to know what's on our own network. An inventory of what you have is kind of the most important thing that you can even use, because it says, who's talking to who, how important is this, how important is that. We use Silk data to identify a lot of services on the network. And I'll show you an automated way by which we do that. It's free to use. You can identify normal behaviors. You can say, oh, well, this trends over time to look like this. A certain host may show up at 8 o'clock in the morning and leave at 4 p.m. or 5 p.m. That might actually be a user. Things like that. When I refer to friends and family, friends are things that are maybe outside the network that we're communicating with. Family is kind of internal stuff. So a good example of identifying services with Silk, you may look at things and say, oh, well, I want to look for what looks like active communications, communications that have had, some sort of handshake, and I want to look at source port 22. You can also use app label and look for app label 22 as well, but we're going to sort by source IP. This isn't perfect, obviously, but it'll give you a good idea of communications going on. We're looking, in this case, at things that are talking out. So when someone actually communicates to it, it talks back out from source port 22. We say, oh, that might be an SSH server. Web servers, very similarly, we can say, oh, we want these source ports, include whatever else you want. Because again, app label can be, I trust app label in most cases, but not always, especially on larger enterprises. But we're looking for, out web here. So things that are talking out from these ports to things that aren't identified as being internal. Some more identifying friends and family. This will basically look for any sort of out and out web things. Again, friends are things that we're talking out to. And then identifying the family are, actually this would be better to not be out and out web, but in web, or int to int, even better. But it will look for things that are talking locally. We see dipset equals local down there. That's where you've identified a list of IP addresses, and you've thrown those into what they call an RW set, and this RW set can be queried through there. So actually doing detection with flow data, when we think about detection in general, we've kind of gone, a lot of people, it's easy to do, signature-based detection. It's now very easy to do reputation-based detection, especially, with all the different malware feeds there are. You can, set up, all kinds of different tools, a lot of free, a lot of commercial tools do that. Also, you can do things like that through NetFlow for just IP addresses. Don't always recommend it, because you get a lot of false positives. But, there's behavior-based detection, things like Bro. Bro, a lot of people will say, well, Bro does flow, but, it's kind of Bro faux flow, because con logs aren't necessarily flow data. Con logs are a little bit different in how they're regarded, not to, bash or anything, because it's a very good supplement. And it'll lead you, obviously, through connection IDs and things like that. But you have to kind of be pretty skillful with Bro to get a lot of behavioral-based detection out of it. And then we go to statistics-based detection, which is kind of something a lot of people overlook, that if you have a good flow solution, you should be able to do some statistics-based detection. And that's both, against hostiles and against friendlies. So you should be collecting statistics on what you have, not just accepting what your network operations says, oh, well, this is what we have deployed, but why not go ahead and test that if you have sensors in the right places to test it? It's completely passive and you have the data, so why not keep an active inventory? One tool that I'll talk about today, it's Flowplotter. So I made Flowplotter a while back, had a bunch of really junky test versions of it that I've used at previous jobs, and finally I thought, well, it'll probably be good if other people have this as well, but maybe not as shoddy. So I've made Flowplotter. It generates visualizations from the outflow of Silk. It basically, so Silk uses all these piped outputs. I made Flowplotter such that it works the same way. So you might have that same exact filter. You just pipe it to Flowplotter with some options, and you'll get a chart. And I'll show you some charts in a minute. It's written in Bash. It's probably kind of clunky because I wrote it, but it's very easy to tweak. It's very easy to add different things. Right now it uses a mix of Google charts, and it uses some D3 charts. Probably converting all those to D3 though, because you can't use Google charts locally without actually sourcing it from the web. At least not by their requirements. It's also maintained on GitHub, and I'll provide a link in a minute. It's also browser independent mostly. Haven't used every browser obviously, but if you can do Google charts, you can look at these. So one example of something you might see on a dashboard somewhere, and you can fit this in any kind of way you want to, but it just gives a good example of we're going to dump kind of all our data from this sample file, data that's not China, it's not the US, and it's not local stuff. And when I say not, I threw a fail on here this time instead of a pass, so it's saying anything that matches this partitioning filter, the NEC or the --DCC, go ahead and kill that from whatever results you have and output everything else instead. So it's dumping everything to Flowplotter, making a geomap based on destination country codes sorted by bytes. If you go back to RW stats, it kind of sounds like what I was saying through there. So that's kind of the same way. You just output it to a file, otherwise it goes standard out. So this is geomap.html. You can throw it into some sort of dashboard or whatever you want, along with these other guys. So this is a basic line chart. I didn't show how it has mouse over and stuff, but it's a Google line chart. Pretty standard. What we've done is dumped all data for the given day, and we've said we want it in bins of 10 minutes. This leverages RW count using --bin size equals 600. The 600 is in seconds. We also want the bytes field. So for a given host, this is how it talked over the course of the current day when I ran this. Here's a tree map. I don't love tree maps, but I got a lot of requests for tree maps, so I threw in a tree map here. It doesn't pivot down right now, but people do use it in dashboards. This one is looking for data that's 1025 and above, both source port and desk port. So it's you're thinking, okay, what's talking high port to high port traffic? I might be able to look at, let's say, the top hosts. Well, this is kind of looking at the top hosts and sorting it, by records. And so, these guys in blue, they are the most, and the guys down here in red, they're the least. Here's your standard, pie charts, bar charts, column charts. It's also based on the exact same data as before. I get a little more results out of this myself. Just big fan of not using true maps, but these also go into any kind of dashboard, also based on Google Charts, also looking at the destination IP by bytes. This one's a little more complicated, and it's better to use against smaller bits of data. So sample.rw is actually a little bit smaller than looking at the whole current day, because again, you're only looking at X amount of hosts. This is predefined. I think I set it to 20 or 24, but it's predefined for a certain amount of hosts, so you don't want to have a ton. It's really looking at a three-way relation of bytes versus packets versus records. It's pretty useful in finding some kind of weird stuff. So like, for instance, you might have this guy at the very top right. It's a very tiny dot. Well, that means it had very few records, but it had a ton of packets and a ton of bytes. So it might mean it's either a very active communication for a small amount of time, or it had very active communication for a bunch of timeouts. So like, again, 30 minutes straight, maximizing the amount of data per record. Here's a basic timeline where we're looking at this host, which is everywhere. I should probably only list it one time. But it's kind of everywhere. This is actually Skype communications, and who it's actually talking out to. So Skype kind of works in a way that's very similar to some peer-to-peer protocols. And so as it keeps going down here, you start seeing a trend of where it's talking back to something, but it's always somebody different. But it's a pretty steady communication on how it jumps forward. So here's your force-directed chart, which a lot of people hate on, a lot of people love it. I don't ever recommend this for the use of detection at all, but more so that you can say, hey, coworker, come check this out. I have this thing in my head that I want to describe to you, but it's really hard to do without drawing it on a whiteboard or without showing you this. And so it'll allow you to kind of output, a set of data and say, oh, who's talking to who, source dip pairs. And this one, for instance, is sorted by distinct desk ports, where we're looking at the top 100 that have talked to as many desk ports as they can, and then we sort around things, and we're preparing it for our coworker or our manager, and we're saying, oh, well, these are the baddies and these are the good guys, and you can do things like double click it and like release the stickiness of it, or change the colors. Your greens are good and your reds are bad, or your reds are good and your greens are bad if you're colorblind in one certain way. But you can change anything however you want, and it's pretty useful for describing that to people that aren't aware of, oh, here's a bunch of line-based text data. And they say, I don't know what you're looking at. I want to trust your word or something. If you have any sort of quality assurance on alerts and things like that, it's easy to show them this and then say, well, now look at this data. You'll see what I'm talking about. So asset discovery, it works a little differently. It's still obviously piped the same way, but it actually has no options, with the exception of you can kind of limit based on percentage, a threshold percentage on how much data you're looking at. Here, it's basically doing all that asset discovery. You run this, and it's going to say, oh, well, here are the servers that I detected that you have running right now. Working on expanding that out a little more. But essentially, you just run this, or you have it run periodically and output somewhere, and you can look at this and say, oh, this is the inventory, of the servers that I might have locally. It's not going to be 100% accurate, but from what I've seen, it is pretty accurate. I mean, even on larger enterprises. Of course, you miss the low guys, because if you have a huge network, you do need to set a threshold, or else this is going to be full of little dots. So I do have a threshold option that you can use as well. So I guess kind of a summary of what it is to analyze with flow data. When we only have PCAP and we don't really have good ways to pivot to the right spot in PCAP, we don't spend any time really of saying, oh, okay, the signature is actually there. That's pretty easy to look at. But scoping the relevant time range is kind of one of the first difficulties, even for the advanced user, and it's a very, very big difficulty for the junior analyst, because he's like, oh, I don't really know the best way to parse through this or do anything, so I'm having issues. But let's say we spend 5% of the time on that. Finding related events. This is probably a little better than it should be. You know, it's 10% of your time. However, reducing your data set to only what you need is probably 35% of your time. You're spending a lot of time, gathering all the evidence, gathering everything you need, maybe to show someone else, or gathering everything to actually put in a report, or do your actual analysis, and then to make the decision on is it bad or is it good, you might spend 50% of your time. With flow data, you really get to spend 80% of your time for a given hour on making the decision of good or bad, and that's because you kind of kill the first few things. So you can still do the validations of the signature and whatnot, depending on certain types of data. Again, that's easy with PCAP in general, but then you're actually sorting through things. Instead of narrowing down your data, you're finding the data where it is, and kind of who talked, and you're saying, oh, well, I can make a Berkeley packet filter for this, and I'll just push this out there, and next thing you know, you have PCAP that you actually want. It's already condensed. So you expand on the data instead of with only PCAP, you're trying to narrow it down. This gives you exactly what you want, and then it cuts out all that time. Barriers to entry, and I'll show you the first bullet in a minute. It's a pretty big barrier unless you have a lot of commercial tools. Be prepared to look at a lot of line-based data, and if you're a 24/7 shop and you're working night shift, this isn't always the best thing. Depending on, it can give you some headaches and do different things like that. We're all probably aware of that, but it's almost all command line oriented, with the exception of some tools that some people write, like Flowplotter. Junior level analysts will have a hard time, even with Silk and its documentation. Their analyst handbook is pretty huge. So it takes a little mentoring to get them up to speed. Once they're there, it's fine, but it's kind of hard to enter. It's also hard to remember all these options. The data is pretty hard to interpret visually. I showed you some graphs, but even then, it's still line-based text data. There's a big barrier as far as making it actually, worthwhile to someone you're showing. Basic Silk output looks like this on your terminal. It's this. It's a bunch of line-based text data, and you're fine with it. You know what you're looking for. But showing this to your coworker that's sitting right next to you, he's like, I don't really see what you're talking about. Highlight it and do this, that, and the other. It's not great. Also, it could be filtered more. So Silk data output, it's very awesome, but it's very creepy, right? So it's like your junior analyst very scared of it. It's not an easy place to go into. It's cold, dark, bleak. Not great, but is there another way? Is there a better way that you're not paying a lot of money for? Well, there is. There's Flowbat, and so some of you may have heard of Flowbat. Not sure, but Flowbat, basically the same output as before, is this. And you may say, oh, that just looks like a web-based front end of the same thing. Well, it kind of is, but it allows you to do a lot of pivoting, and without having any of the prerequisite knowledge that Silk might require. Silk is the Flow Basic Analysis tool. It is a graphical front end that uses the Meteor framework on the back end. It's very easy to set up. We've made a lot of scripts that will literally get you not just Flowbat, but Silk installed as well in a matter of just 15 minutes. And that's probably even pushing it. It depends on your download speed. But its biggest thing is it has a lot of very rapid pivoting that you can do. And I'll show you an example in a minute. Doesn't have quite the graphing capability of Flowplotter yet. Working on that. But again, it was Chris Sanders and I, who really, spearheaded this whole thing and pushed it and made it. And we said, oh, well, this is actually great for everyone. Let's actually make it, a very polished tool. And, if anybody has bugs, they can submit them, and we fix bugs all day long. So here's a, kind of an idea of how Flowbat works. You'll notice there's an autocomplete of all your terms, so you don't have to remember all those things. It'll execute. There's all your data. And again, this is on a tiny VM of a ton of records. We added the, where any port is port 22. Re-execute. We get our data that we need. Let's say we want to look into, let's sort all this data here, which would normally require some RW sort stuff and a lot of different knowledge of different Silk tools. Well, this happens on the fly immediately. Then you can narrow in on that. And it's, there's what you want. Another example, here we look at the query builder for when people don't know anything about Silk at all. The first is kind of for the Silk veterans. This is for, people that actually, are kind of new to Silk, down at the bottom you'll see it's building the query as they build it out. There we look for basically the IP that this is running on, actually. And then we're going to do some stats by bytes. We're going to look at all the destination IPs. You'll notice it built out a little more on the query. Query is a little more advanced than what you typically run in Silk because it does a little bit of handling of files. But there you go. There's a bar chart for your top destination IPs by bytes. You can also generate a table. Again, switching back to records, just the records. The pivoting from this, let's sort it down first to just the 5 tuple. So now we have just source IP, dest IP, source port, dest port, protocol, as well as the starting time, but I like starting time at the beginning. And I want to go ahead and say that I only want to look at the 5 minutes before and after. So you'll notice it added in this active time, which would have been a bear to just calculate and say, oh, I want 5 minutes. So it would be a bear otherwise. And so there you go. There's some more pivoting in Flowbat. So to really get Silk and Flowbat running, 6 commands. You have 2 to 3 questions on each script when you run it. And once it's done, you'll be able to go to the address that it's being installed on, and you'll be parsing all your data. Literally, it's that easy. Like there's no other setup at all. It's that easy. You can assign temporary directories once you're in Silk. You can make sure they're writable by the user. But you can assign pretty much anything that you want to in there. You identify where the configurations are once you're in Flowbat. It's very, very easy to set up. So in conclusion, flow data, even by this audience alone, the population here probably busted your mic. Flow data is grossly underused and grossly underrated. There are alternatives to flow data, but they're not as good as flow data. And what I mean by that is flow data is meant for speed. It's meant to be simple. It's meant to get you where you're going, not to get you the answers. And flow data, it's so easy to set up. I mean, I just showed you 6 commands to set it up. And I mean, it's by far the easiest way to get where you're going to make decisions in the end. I mean, you can have every solution set up in the world, but if you can't pivot to those solutions to the right spots, they won't do you any good. If you have any questions, I'm going to throw Chris Sanders out as well. Probably contact Chris Sanders, or you can contact me. There's my email. Go get the book or read the blog, Applied NSM. You can grab FlowPlotter there, and you can go get Flowbat at flowbat.com. It's actually housed on GitHub. Any questions?
Just walk back really quick to the other commands.
They're also on flowbat.com under the installation tab.
How does Silk have a facility for streaming analysis?
So by streaming analysis, do you mean live records that aren't binned yet?
No, binned records, but not searching historical on this database.
So as soon as a record is available, like as soon as that timeout has occurred, that record is queryable. So if you wanted to run something and constantly get the last X amount of minutes, for instance, if you want to look for certain IPs or whatever in a list.
Like as it comes in, can I take that newly binned flow and the Silk have a facility to say, okay, you've got a new thing in, pass it to this script to run some analysis on it?
Yeah. So I only mentioned Silk here, and I basically mentioned the easiest form of using Silk. Silk actually has a thing called Silk Analysis Pipeline as well. It's actually doing all this on the side of Silk as well. Not even using Silk specifically, but taking from RW Flowpack. There's also, you can set a lot of things up. It has its own Python module called PySilk, which can do a ton of different stuff as well. We actually, just to make Flowbat work entirely, we've used only the Silk, the inherent Silk tools for the analysis tool set. I mean, it's got a ton of different stuff that we can roll out and deploy, do basically anything you want to with it. I mean, it's very, very powerful.
Is there any way to set up like a query or something like that that would look for certain data and then some way to notify?
Yeah, so
if this happens, then an email.
actually, let's see. So Flowbat itself, do you mean in Flowbat or do you mean in Silk? Either one? Okay, so in Flowbat right now, you can set these things up. Say if I want to, execute this particular thing, every, 60 minutes, I'm going to hit that execute. It's going to reset that 60-minute timer and then do this every 60 minutes. If you had some sort of, let's say, some sort of IP set where you said, I want, we'll say bad guy 1 and, bad guy 2, and bad guy 3. That was creative. BSides example. Now, yeah. And then I could go ahead and create a query that looks into that. Any IP set, so either one. And you'll notice the input's already there. We did any set equals this gibberish, which is actually according to that up there. We're using every protocol just in case you didn't specify something for some reason, and some other things that Silk requires. And I bet we don't have anything because those IPs didn't occur. But in our dashboard, we could go ahead and set that up to say, add query to dashboard, bad guy query. And we want to run this every 1 minute. And then whenever it occurs, you'll see all the records for it. And they'll actually be, you can parse them on the dashboard instead of having to drill into them. Set it up to display 100, which will destroy your dashboard basically because it'll have a bunch of records on it at that point. But it's that easy. We have actually tickets for having some sort of email notification, things like that. But we also have like 100 more tickets. So it's all about priority and how people push them up. Any more questions? Okay. Well, I appreciate the time, and hopefully you get out of here and you go set up some Silk solutions or some sort of flow solutions because you need it if you don't have it.